Let's talk about the conjugate a little bit. This is a really useful strategy when we're solving limits that can't be easily solved by just plugging in or substituting in the limit value. So the way the conjugate works is very simple. It's based on the idea of multiplying by 1. And so think about this. If I told you I had 4 times 1, we all know the answer is 4. If I told you I had 4 times 2 over 2, that's a fancier way, I don't know if fancy is the right word, but it's a fancier way of saying 4 times 1. It's still 4. So if I told you I had 4 times x over x, well, x divided by x is technically 1, so it's still 4. And this is the idea of the conjugate. The conjugate's when we're going to multiply something by 1. Anytime you times something by 1, you never change the number. If I tell you I have 75 times 1, I still get 75. You don't actually change the number. So it's kind of a useful strategy when you want to change something to look different. And I'm going to show you an example to make sense of this. So here's a limit problem. The limit as x approaches 3. For radical x plus 1 minus 2 all over x minus 3. If I tried to plug in 3, if that was my strategy, if I plugged in 3 here and a 3 here, I'd get in the denominator, right here, I'd get 3 minus 3, which is 0. And we know you cannot have 0 in the bottom of a fraction. It doesn't even matter what's on top up here. If there's a 0 in the bottom of the fraction, that's an issue. So I'm going to backtrack a little bit and say, okay, scratch that plan. I can't plug in 3. Let's try something else. If I times this fraction by 1, then I'm not really going to be changing this problem at all. So I'm going to times it by 1. Except I'm not going to times it by that one. I'm going to times it by kind of a weird fraction. Watch this. I'm going to times this whole entire thing by a fraction that matches on top and bottom. I could do 3 over 3. Times it by 3 over 3. Well, that's technically 1, but I don't want to do 3 over 3. I want to do this. I want to do radical x plus 1 plus radical, or plus 2. And I'm going to do the same thing on bottom. Radical x plus 1 plus 2. This is the conjugate. Now technically this entire fraction cancels out to be just 1. And so I'm only timesing by 1. I'm not changing anything. But the nice thing about this setup is we're going to multiply these quantities on top and bottom, and we're going to get a cleaner answer. So I'm putting some parentheses around everything. And let's go down to the next step and rewrite this limit. The limit as x approaches 3. On top, we're going to do a radical times a radical. So a radical times a radical cancels, and we get left with x plus 1. Then I'm going to do square root x plus 1 times 2. So I'm going to get plus 2 square root x plus 1. I'm going to FOIL out the top. Then I'm going to do minus 2 times radical x plus 1. So I'm going to get a minus 2 radical x plus 1. And then I'm going to do negative 2 times 2. And I'm going to get negative 4. All over all this stuff on the bottom. Now I could do the same process on the bottom. I could FOIL it out, but I'm not going to. I'm just going to leave it as x minus 3 for the time being times radical x plus 1 plus 2. And it's pretty messy, but if you notice, the positive 2 and the negative 2 up here are going to cancel. So 2 squared x plus 1 minus 2 squared x plus 1 cancel. And I have technically x plus 1 minus 4 left on top of this fraction. Limit as x approaches 3. And it's all over x minus 3 times radical x plus 1 plus 2. Now I'm going to modify the top of the fraction even more. I'm noticing on the top of the fraction that if I put this plus 1 and minus 4 together, I can simplify things up. So I'm going to erase the top and change that. That's really 1 minus 4 is a negative 3. So let's erase this. Let's use my eraser for a second. Normally I just write this out on another step, but I'm kind of running out of room. This is really x minus 3 on the top of this fraction. So I noticed something. If I have an x minus 3 here, on top and on bottom, they're going to cancel. So now I get left with this. I get everything to cancel out, and on top of the fraction I'm left with 1. So I'm going to rewrite this limit again. I'm going to go to the next page here, and I'm going to have the limit as x approaches 3 Now on top of my fraction, all I have is 1. And remember, like, we can flip back to the last page here. Remember what's left on bottom down here is square root x plus 1 plus 2. So I have square root x plus 1 plus 2. Usually when I'm doing these limit problems, I'm trying to get rid of the fraction altogether, because if the fraction's gone, then I never have to worry about getting 0 in the denominator. But now I'm thinking, why don't we just plug in our limit? Why don't we plug in 3 for the x and see what we get? We're going to have 1 over square root 3 plus 1 plus 2. And that is 1 over the square root of 4 plus 2. And we know that the square root of 4 is 2, so we have 1 over 2 plus 2, which is really 1/4. And so my final answer for my limit is 1/4. That is the conjugate.